For this video, I'd like to talk about the concept of prime factorization. So this word prime comes from the idea of prime numbers. So just as a refresher, a prime number is a number that is evenly divisible by itself and 1, but only those numbers. So for instance, a number like 2, 3, 5, 7, 11, 13, 17, 19, and 23. I'll go one more. And it keeps going on forever. In fact, the prime numbers were proven to be infinite back about 2,300 years ago by Euclid. So, as I was saying, these numbers are only evenly divisible by themselves in 1. So take a number like 7. If you divide 7 by 1 or 7 by 7, you get whole numbers. 7 in this case and 1 in this case. However, if you divide 7 by anything else, you will end up with a fraction. And so we call 7 a prime number because the only evenly divisible numbers that go into 7 are 7 and 1. So none of these other numbers divide evenly into it, which means that 7 is prime. A number like 4 can be divided by 2 and can still be a whole number. So 4 is not a prime number because yes, it can be evenly divided by both 4 and 1, but there's also other numbers, or in this case just one other number, that divides evenly into it. So 4 is not a prime number, but something like 11 is a prime number because the only numbers you can divide 11 evenly by are 11 and 1. So with this idea of prime numbers, we want to think about what prime factorization is. And basically, every number can be broken down into a product of unique prime numbers. So let's look at just a couple simple examples and then we'll jump into this one. Let's say we're looking at the number 20. 20 is a product of, let's say, 10 and 2. And we can break down 10 into a product of 5 and 2. So 20 is really just 5 times 2 times 2. But notice these are all prime numbers. You can't break them down any further. 2 is really just a product of 2 and 1. But we're not going to include 1 in this list because 1 is not a prime number. And we want each number to have a unique prime factorization. So they're always different. Every number is going to be different. 20 is the only number that is a combination of 5, 2, and 2. There is no other number that has this prime factorization. And so if you include 1 as a prime number, then they no longer are unique. So like I can multiply it by 1, 1, or I can multiply it by 2 1s, or 7 1s, or however many 1s that I want, and because of that, it's no longer unique. So that's one of the reasons why 1 is not a prime number, so that we can keep prime factorization unique to each different number. But let's start jumping into these problems. And for a number like 32, and really any number, the first step here, at least this is what I do, is I make a tree. So I start with 32, and I put 2 branches. And I ask myself, what 2 numbers multiply to give me 32? And whatever 2 numbers work, you can write those down. You can use 16 and 2, you can use 4 and 8, you can use 1 and 32, but that one won't be helpful because we want to break these down into prime numbers, so you don't want to write 1 for any of these. So let's just say 16 and 2. And once you reach a prime number on one of your branches, you can stop. So we can't break 2 down any further because the only thing you could break it down to is 2 and 1, but in that sense, you can kind of just go on infinitely, which is not what we want. So we're going to stop at 2 because we're not including 1 as a prime number, so we don't break numbers into that. Now 16 is not prime. We can break that up into a product of 2 other numbers, namely 4 and 4 or 2 and 8, whichever one you want to use. And then 4 can be broken down into a product of 2 times 2. And now notice the ends of each of these branches is now a prime number. And once you reach prime numbers, you stop. And what I would recommend in the beginning is maybe just circling these or underlining it, or just highlighting in some way which numbers were the ends of the branches. And then this number 32 is simply just a product of all of these ends of the branches. So in this case, there are 5 2's multiplied together. So I'll just write all that out. So 32 is the only number that is a combination of 5 2's multiplied together. No other number has this unique prime factorization. And 2 multiplied by itself 5 times could be written as 2 to the 5th. So you might see it written in both different scenarios. So over here in this box, we would just write 5 different 2's multiplied together. And this would be the prime factorization of the number 32.